Good morning students, so welcome back to digital electronic class. In today's class also we are going to continue the third unit, that is nothing but programmable logical devices. So in that, what actually in today's discussion would be, we are completely discussing about ROM, right? So in today's class we are going to discuss the same continuation of ROM. How do we design PLDs? What is PLD stands for? Programmable logical devices. Okay, so for that we just taking the first part, that is nothing but ROM. So in that, what is the first thing we are going to see? We are going to see its block diagram. As we have discussed in the previous class also, its block diagram of it, how do we design ROM? Basically what is ROM? ROM is nothing but read-only memory. So what is that read-only memory for usage of it? It is going to store the data, depends upon the number of information what you had, and that depends upon the size. So how do we design the size and what are the memory capacities there? That part we are going to see by seeing its particular diagram. So that diagram is nothing but its block diagram. So in that, what I am taking one block. Okay, so in that, what is the input combination I am taking? Suppose I am considering 2 power n into n. So this is nothing but my combination of inputs. So in that, what I am taking some k, not n here, I am taking some other variable k. This is the kth combination. K number of lines is coming over here. So this is your k lines. Okay, suppose this is your k1, k2, k3, so on, kn. So this is your input lines we do have, and n is nothing but number of outputs. So n indicates output data. So this is your n. So n indicates what? Actually it's an output. So based upon this, we are going to design what? We are going to design the ROM. So read only memory. So in that, what is the first thing we are going to do, students? So we are going to see its block diagram, where k indicates the input lines. Input lines depends upon the address. To do any kind of memory part, we have to go for three part of it. One would be the address bus or address lines. Second is giving the information in separate lines, that is nothing but the memory location. We should know the memory location. Third part would be what kind of operation you are going to perform. So whether you are going to perform write operation or whether you want to read out from it, that particular part we are going to see. So in ROM, what are the things we are going to do? We only going to read out. We are going to go for only reading the particular information. For that we required only read operation. So here what is the thing we can do it? We can perform a read operation only. So that point you have to keep in your mind whenever we are designing the ROM. So next thing, after drawing its block diagram, next part we are going to see its implementation. How do we implement? By using the logic gates. So let us take one problem. So internal design, a question is given. So I'll write over here. So design 32 into 8 ROM, 32 into 8 ROM, decoder circuit, design 32 into 8 ROM, decoder circuit with connections for each block. So this is our question, students. So they asked to find what? They asked to find the design the 32 is to 8 ROM. So we have to design this by considering decoder circuit, and we have to connect for each block. For doing these things, I'll show you how do we design the 32 is to 8 ROM. So let us see this thing. So I'll design here. So I'll just take it, I'll just write over here. So first thing, what is the thing is required? We have to make one block diagram, right? So in the block, what is the size given? The size mentioned over here is 32 into 8 ROM. This is our size. Clear? So in that, what is this thing we have to see? 2 power k. 2 power k means what I can write for 32? I can write 2 power 5 into 8. This one I can write. So what I am doing? I am taking, how many k lines should be there? There should be a 5 k lines. So in that, the input, whatever we are giving, there should be how many lines? There should be a 5 lines. So that 5 lines I am mentioning in this. So this is what side? This is our input side. So input side is given by the letter I0, I1, I2, I3 and I4. This is done. Next thing, they asked to design what? Decoder circuit by taking this combination. So 32 will be this much. And now 8 lines would be what are the things we need to do? We have to make into 8 lines. How do we do it? For that, what is the thing we have to do it? We have to complete this combination. 32 value we have to take. I'll mention here. Little bit I'll tilt this thing so that it will be visible. So what we are doing, we are taking the 32 inputs value, so little bit I need to enlarge this thing so that it will be visible properly. So see here, I'll enlarge this particular part so that complete 32 lines we have to design. Okay, so what we are doing, students, so we are taking input combination. So this is a complete block, like this we do have. So what is the size of it? 32 into 8 ROM. Okay, for that what we are doing, how many inputs combination based upon the block diagram? It is 2 power k into n, right? This is there. What is 2 power k? K is nothing but number of inputs. 32 I can write 2 power 5. So I do have 1, 2, 3, 4 and 5. So these are my inputs lines, I0, I1, I2, I3 and I4. Next thing, I have to make the output arrangement. For output arrangement, what is asked in the question? What is the thing they gave? They gave 32 values. So what I'll write? I'll start from bit 0, 1, 2, 3. Likewise, I do have, what is the last bit should be? 31. So before 31, what should be there? 30. Then before 30, 29, 28. Like that, so I have 0 to 31 bits. Total 0 to 31 make it as 32. So those number of lines you have to make. These are my number of lines. So this thing you have to keep in your mind. There may be so many dashes are there in between that. So dash, 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 you can put it, or you can write all the numbers. So this is nothing but your combination. So we made the combination. So next thing what you have to do, you have to make the 8. What is 8 indicates? 8 is nothing but your address bits. Address bits should be, we are giving one particular gate for it. So what I am doing, I am designing one gate. First gate, second, third, fourth, fifth, sixth, 7 and 8, right? We'll start from A0, A1, A2, A3, A4, A5, A6 and A7. So these gates, number of gates we made it. Next thing, we are extending the lines. In between dash dash is there. Okay, so now as we have seen in the previous class, convention symbol and the programmable logic array symbols are this way. Only single lines you have to put, and when you giving the connection, the line should be single. So what we'll give it, we'll make one single lines like this. We'll try to join with one particular line. That can avoid the hardware connection, more complex hardware connection. We can simply make one lines. So this what we did, students. So we taken 8 address lines we do have, and how many inputs lines we do have as per this 32 means 2 power 5. That 5 indicates 5 is nothing but k. K input lines we do have. So this 8 is done and this is done. Which one? K. Now what about this 32 indicates? That 32 indicates those number of combinations. So we have to take the combinations. So how much should be the memory capacity? Memory capacity should be 32 into 8. So it should be, multiply it is 256 byte of information we are going to store in this particular location. So this, they only just asked to draw the block diagram. So we have drawn it. What we did, we took the 32 into 8. The 32 we can write 2 power 5. So we do have 5 inputs. So these are our input values. So we mentioned this is our inputs. So inputs is done. Next thing, what about this 32 indicate? Those are nothing but your combinations. So 0 to 31, total is 32. What about this 8 indicates? Those are nothing but your combination from where you are giving. Suppose I have connected OR gate. So this is your OR gate 7, OR gate 6, OR gate 5, OR gate after 5 4, before that 4, 3, 2, 1 and 0. So these connections we have to give it to these gates. So if at all they give anything, like any function they gave in the question, A7 value. Suppose in the question they gave A7 is equals to summation of 1, 5, 6, like this they give. What we'll do, wherever 1 is there, we'll put cross. Wherever 6 is there, suppose here 6 is there, we'll put a cross. They will give, wherever they gave connection, that particular thing will put a cross. So in the question they did not mention anything. When they mention it, we'll do that way, crossing of it. Okay, so this is the way we will design given ROM into a specific dimension. In that particular thing, what we did, we took the one particular gates and we just put a lines over here. So this is the way we can design the given problem into a specific format. That is nothing but the given question with respect to given size, we have designed a ROM. Take down the second problem, students. So in this, what is given? They asked to implement. The question here is implement. Second question. So again, implement 32:8 ROM with A7 is equals to A6 is equals to A5, A4, A3, A2, A1 and A0. This is given as first. A7 is 0 to 3, 29. So summation of 0 to 23, 29. 0 to 3, not 23, 0 to 3. 0 to 3, 29. Next, A6 is 2, 29 and 30. Summation of 2, 29 and 30. Next, A5 is given as 0, 3, 29 and 31. 0, 3, 29 and 31 with summation. They gave this thing. Next, A4. What is A4 value given? A4 is 0, 1, 3, 31. 0, 1, 3, 31. Next, A3. Next, A2, A1 and A0. So these are our values. So what is A3? A3 is 1, 28 and 30. 1, 28 and 30. Next, A2. What is A2 value we do have? A2 is 0, 1, 3. 0, 1, 3. Next, A1. A1 is 0, 3, 29. 0, 3, 29. So next 0, 1, 3, 31. These are the question they gave in the question. So what they said? Implement 32:8 ROM with given specification with decoder circuit. Okay, decoder implementation or decoder circuit they gave. So in this, what are the things we have to do? So these are our given address bits are given A7 to A0. Same implementation we should do, but see, it's slightly different. That will I'll show you now. So we'll take down these values, whatever the given in the question, and we'll try to design it. For designing these things, what is the thing we required? We have to implement by using 32:8. So exactly same as the previous problem. So in this also we do have 32:8, 5 inputs, 32 number of combination of that one, 0 to 31 we do have. Next 8 is nothing but address line from A7 to A0 to A7. We did this thing. Next thing, they gave value A7. A7 is 0 to 3, 29. So 0. We'll start from A7. A7 is 0. We put one cross. Okay. Then next is 2. We'll put a cross. Next is 3. So 0, 2, 3. Then 29. So this is a 29. So when they gave connection, we wrote it for A7. So next A6. What is A6 value they gave? 2, 29, 30. So for 2, we'll put a cross. 29 and 30. That means that particular location, that memory has been stored. Out of these number of locations, in that memory location, A7th, whatever data they have stored in that one particular location. So that is the way we can mention. Likewise, we can go for A5. A5 is 0, 3, 29, 31. So 0, 3 is there. So we'll put it 3, then 29, then 31. So we're done with this thing. This is 31th line. This is 29, 3 and 0. Likewise, we go for next thing, A4. What is A4 given in the question? 0, 1, 3, 31. So 0, 1, 3 and 31th location of the particular bit. That bit we have done it. Next thing we do have, next particular part is A3. So A3 we can write 1, 28, 30. So 1, so 28 bit is this thing. Next 30. So in between whatever the numbers are there, you have to mention 4, 5, 6, 7, 8, 9 like that till 28. So we have to mention those number of lines also. Okay. So whenever you're designing, you take a bigger space and try to design by taking that particular value. So you can put a dash in this way. Okay. So Likewise, next we proceed with A2. What is A2 is given? 0, 1, 3. So 0, 1, and this is a third location. Likewise, I do have A1, 0, 3, 29. So 0, 3 is here, and 29 is this thing. Likewise, A0, 0, 1, 31. So 0, 1, 31. So by taking this particular thing, we can say that our storage of memory has been obtained, and given whatever the values they gave, we have designed for particular ROM. So what is the conclusion in this, student? So what are the things we have to do? So first thing, the given size we have made it, we done with that particular thing. We mention the inputs, then combination of it, then we'll mention this particular complete address. After that, for each specific address, they gave one mean terms. That particular mean terms, we have to design in this way. So this is the way we can design. What is the answer for it? It is 32 into 8 ROM for given specification. For that particular specification, we have designed 32 is to 8 ROM. That means 256 bytes of the memory. That also be done. So that particular thing you have to remember when we are designing. If they gave questions, it's not necessary they mention all the values, they can give some of them. So that particular connection you do it, remaining only you have to give one line, vertical and horizontal, that will be empty. Because if they are not mentioned remaining don't do it. For whatever the value they mention, that value you have to take and you have to design and you have to implement that ROM combination. So next we will see PLDs. PLDs are of how many types? There are 3 types in that. One is, this is ROM. Next would be PLA, that is programmable logical array. Next is PAL, programmable array logic. How do we design? By taking 2 types of gate only we'll consider. One is AND and OR. One time, one gate will be fixed, another gate we will take and we will design. Second time, suppose AND is fixed, by taking OR, gate combination you want to design. Similarly, you can put OR is fixed and you can design by using the AND. So this is the way we can design for given conditions. So by taking that one and by taking some more problems and how do we take PLDs into the practical implementation, that also we will see. And logical part, how do we take this logic diagram? This we only be done with ROM, right? So in that we have designed this size. They can give different also, 16 is to 4 or 64 is to 2, whatever the values they gave, that value you have to consider. If they mention in the question, the size is different. Suppose the question is 16 is to 4. What we will do? 16 means I can write 2 power 4. Those 4 indicates k lines. So k is equals to 4 lines. And this 4 indicates, it cannot necessary 4, I can take any other number like 8. That 8 indicates these are the address of 8. If you multiply both, 16 into 8, what you will get? 48, 6 1 is 8, 128 location you will get. These number of locations you have to do. So this 16 means 0 to 15. Put a lines and go for that particular design. Clear? So I'll give one question, try that one and show me the answer. And if you had any query, you can ask about that. So before proceeding with that problem, you first note it down this thing, diagram of it, practice it, then take the next question based upon this question. Okay, so do it this thing, then I'll give the next question to solve. So take down second problem, students. Third one, you try that question by yourself. So implement (16:4) ROM with So implement 16:4 ROM with A3 is equals to summation of 0, 1, 5. So A3, A2, then next is A2, A3, A1 and A0. So these are the address values. We do have location value 1, 7, 8, 14. Summation of 2, 6, 2, 10, 11 and 12. And summation of 1, 3, 5, 7, 9, 12. So these are the given by using decoder. So by using same decoder circuit, try to implement this third problem. Okay, so in this also 16 is to 4 means 16 is 2 power 4. 4 number of inputs, 16 locations, 0 to 15 combination, and 4 is nothing but addresses of it, A3 to A0. By using the decoder, you try to implement and get the answer. If any doubt you do have, you can ask about it, but see the complete video. If you understand the complete video, then only you can able to implement. Okay, so thank you for today's class.